Hello everyone. So I'm going to uh, do the S-Concrete software tutorial today. So you guys can follow me to do the S-Concrete software. So I'm writing, so I'm making a new slide. So the uh, class today is on S-Concrete software tutorial. So we'll solve a S-Concrete software tutorial. We'll solve a concrete column design using S-Concrete software. And this will be counted as your Monday class, Monday of 15th November 15. So first of all, what is S-Concrete used for? S-Concrete used for column design, also used for beam design, and also used for shear wall design. Three things. And column can be rectangular or square shape, and also for circular columns. So it does not matter rectangular, square, or circular columns. And also it can be used for beam design and shear wall design. So today we are using the S-Concrete software, and design a column. So we'll design a rectangular column. First of all, I'm writing the problem statement. Rectangular tight column design, or rectangular or square, it depends. Square, rectangular, rectangular square tight column design. So what are the given parameters? The given parameters are F prime C, we can assume that it's 50 MPa, and Fy we can assume 450 MPa. Axial force vertical downward 2000 kilonewton. But you can do little less, like 1400 kilonewton. Moment one, just a moment in one direction is 450 kilonewton meter, and moment 2 is also slightly different, 550 kilonewton meter, and the shear in both directions are say 300 kilonewton. So this is the problem statement. The concrete parameters are given. Material properties 50 MPa, 450 MPa. Axial force is downward for 1400 kilonewton, and there's also moment 1 and moment 2. So I'm making it a little bit one more. I'm adding one more parameter, that is axial uplift equals to 200 kilonewton. So now I'm going to, this is the problem statement, and we're going to the S-Concrete software now. So first of all, we are doing the, if you go to the new, so you're following the building standard, which is CSA. We are following the Canadian, but within Canadian there is 2004 and 2014. So you're following the 2014. But in case if you need to do the American code, so CEE 2002 code to 2014 code, ACI is the American Concrete Institute. So those are following American Concrete Institute code. and also CSA 2004 and 2014. And you can also visit follow other country codes too, for example European code. But for our case, we are following Canadian code and the latest code, CSA 2014. Select 2014. Then I need to do it again. So CSA 2014, and unit is metric. If it is American one, if we click the button here, if it is American, then we need to click on US or imperial. In that case, then it will be feet, keep feet, pound in that scale, inch. And we are following Canada. In Canada, following metric method. So then metric unit. So then it will be kilonewton and meter, not feet and inch. And keep it will be kilonewton meter or newton and meter or millimeter. So then it's metric unit. But type Canadian type. So it will be like 10 amber, 15 amber, 20 amber, 35 amber, something like that. It will not be number 3, number 4, number 5. So you're selecting Canadian and member type rectangular column. What are the options? It can be circular column or it can be wall, rectangular wall that is used for shear wall. And as you see, there's a T-beam and L-beam. If you do the beam design, then it will be T-beam or L-beam. If it is shear wall design, then you need to follow the rectangular wall. But since we are doing the column design, so either you can choose circular column or rectangular column. For this particular problem, it's given that it's a rectangular column, so choosing this rectangular column. If you are doing circular columns, spiral column, then you're supposed to select the circular column. Once again, if you want to do the spiral column, we need to select circular column. And when we'll do the shear wall, then we need to select rectangular wall. If you select rectangular wall, it will be a shear wall. So for our particular case, we need to select the rectangular column because we're doing a tight column design of rectangular or square shape. So building standard CSA 2014, unit metric, bar type Canadian, and member type rectangular column. So then we select OK. Other cases, like if you are not sure what to select, then if you see in the left hand side, there are some signals there, shapes, options there. This is the beam, the first tier beam, and this one, the square shape one and the circular one. These are the two columns. And then there is wall. If you select wall, then it, as you see, this is the wall option. So those four are for wall. The first one, if you click on this is a wall. So if for your project, if you want to do the shear wall design using this as concrete software, you need to select this option. If you see in the left hand side, this under this writing wall, you need to select this one in order to do the shear wall design. So in your project, when you'll do the project, then you'll need to select this for shear wall design. And for a project, if you need to do the beam design, so then you can select one of these options, this one or T-beam. If you're doing T-beam, then this one. If it is an end beam, then this is the one for end beam, and this is for rectangular regular beam. For our particular example, we are doing the rectangular column and tight column. So we are selecting in the left column, in the left side, we are selecting this box, black box. If you select circular one, it will be a circular column. If you select a rectangular, then it will be rectangular or square tight column. Now this is done. So then we need to select the material properties. If you see the problem statement, our material properties F prime C equals to 50. Oh, and another option, another thing is 205,000 MPa. So this is the modulus of elasticity of steel, 205,000 MPa. If that is the case, so we are minimizing this. Our F prime is 50, 450, and 205. So for material properties, you need to go to edit and section, and here you can need to, if you go to the bottom part, material properties, so then 35, those are the by default given. So our problem statement is 50, 450, 205. So our case it's 50. and 450, and we are also assuming the vertical route and the tie bar are same FY. If it is different, then you need to declare it differently. So for our case, we're assuming that tie bar is same, so we're putting 450, and for still we are putting 205. So for your assignment or project, you need to know the material properties and put it accordingly. Don't just put the same number that I'm putting. So put it, for this example, it's F prime 50, 450 for vertical bar, Fy for tie bar is 450, and 205 for steel modulus of elasticity. And if you have a different modulus of elasticity for concrete, then I need to change this number. For my case, in this particular problem, I'm keeping it same, but if you have a different number, you need to put it there. So then we can put it, okay. So now I'm showing it once again how I got it. If I go to edit and sections, so then in the lower part, material properties, F prime C is F prime C value, Fy value, Fy value tie, and one thing is for shear wall. This is the Fy shape. You need to select for shear wall. You need to select this. For vertical, in for column, this one is for vertical reinforcement, and this one is for tie bar. And this is steel modulus of elasticity and concrete modulus of elasticity. Now, in the same one, we need to put column width and depth. So and also need to put clear cover, outer clear cover, inner clear cover. In your assignment problem or project problem, you need to remember the direction of the column. So if you see the z direction, z axis h, the dimension h is along z axis, and along the y axis this dimension is b. So in your whole building design in the project, remember to keep in the same direction. The same direction that is z, you need to put h in that direction, that dimension, and along the y direction, the dimension will be, column dimension will be b. So h and b, and the clear cover is 40 and 40 for this 40 40 is for interior. So you need to check the table that I showed in the course note. So what is the clear cover? The clear cover is different for interior column and exterior column. It's not the same value. So, and also the value is different for exterior column, or there's a corrosion potential. So then the clear cover is even more. So you need to, for now I'm keeping 40 and 40 for, but clear cover you need to put a different value depending on the interior column or exterior column with a special case, chloride content or not. Also need to remember the difference between clear cover and cover. One of them is from the steel rebar center of the steel rebar diameter to the end of the column, and the other one is from the end of the steel rebar to the end of the column. So don't mix up. This particular one, it asks for clear cover, not cover. Do not put the cover input. It's a clear cover. So then you need to remember the difference between clear cover and cover. So you need to put the from the center of the steel rebar to the end of the column. So this, I'll come back to the dimensions. I'm keeping the clear cover same as it is now, for now. And there are two more things. As I showed in the class, there is two types of column: short column and long column. Short column and long column, or slender column. Long column and slender column are same thing. In our course, we are mainly teaching and learning the short column. We are not putting much emphasis on the long column. So if we need to design the long column, then you need to put these parameters, slenderness effect. So you need to fill up these parameters for long column. For short column, you can ignore this part. You can ignore this part for a short column. And other thing is, in the right hand side, seismic option. See the box, seismic option. In this case, those are the check. Like, see the seismic option for CSA to A23.3. No additional checks. and depending on the clause, they need to follow the clause. Okay. And one more thing, so if you edit, you can go through edit section, or alternately you can go through, click on this button, see this section, the T sign, so that is called section. If you can also click it, and you will get these values.